ever. He was just, he cussed, he swore, but he was an old Boeing engineer. So I said, my students are gonna have to get used to having someone like Gene around. So I said, this is the right guy for, life lessons from Gene. So when we first got this going, we launched it in our build area, and Gene runs over to me and says, "That's going to be too fast." I said, "What do you mean, Gene? That's gonna no." So we timed it out, and I watched the ball launch from here, and we had it 15 feet away, and it was supposed to be, it can't be more than 15 feet a second. So 15 feet away from the goal. So you watch the ball run out of here, and then I counted 1,000, 2, and sure enough, about 1.5 seconds, the ball would go through there. I said, "Gene, no, we're not going to exceed the speed limit because we're 15 feet away, and we're going to," but no! So he whips out the engineering book that he has been keeping track of all of this, and he says, "According to my calculations here, this ball is going to go out of here 20 feet a second." I said, "Gee, no, there's something wrong in your math." And I couldn't believe this, but so he wanders out and he does the math and discovers that we, instead of a 9-inch wheel, we were using an 8-inch wheel. So we redid the math, and he actually discovered that we were running at the right amount of speed. So having an old Boeing, sorry, Paul, an old Boeing engineer, well, you're young still, so, A, old Boeing engineer, B, inappropriate old Boeing engineer, right on the money. A couple things about this. Now, I've been criticizing other people for taking bad pictures of the robot, but here's my little mea culpa, because I took a really bad picture of our robot. One of the things about every once in a while, FIRST is going to throw at you a game where you deal with these foam balls or soccer balls. Sort of, we're talking about balls in the underneath 12-inch sort of diameter. One of the things that we've discovered is if you have a roller, and you can't see this at all, I apologize for that, but there's a roller, a 3-inch roller in front, and this 3-inch roller is spinning all the time. And it's about it's about 26 inches long, and it's just spinning there. And this is the most amazing thing for capturing balls, because a ball will come in here, be captured by the spinning the tube, and then it will just suck right into the ball handling mechanism. So that's, if you're going to design a ball handling robot, one of the things is you want round edges. We have sort of a round edge here, we have a round edge here, we have up here you can sort of see these things, pulleys. Okay, sorry, you're the warm-up audience. You should see me at 1, at 2. So what these pulleys are also a round object that if you spin them right, then these balls will just pop in and out. So one of the things for a ball handling mechanisms is you want things to suck balls into the mechanism, and then there's a pulley and a belt that goes up and down here. So the ball's right on this belt, and they just spin up the ball handling mechanism. So that is sort of all the ball handling mechanisms in one slide, but unfortunately I don't have a good showing of what the vacuum type of thing looks like. With this is a cool thing, but it's too dark on the screen. Boy, too bad. Yeah, try the lights. Oh man, well, it kind of made it Fortunately, this robot is here. This is the 488 robot that's sitting on top of the table, and you can see this. Now, this isn't a mechanism or mechanical device. I just thought this was cool, so I said, it's cool, we want to show it off here. So what 488 needed is, on the end of their telescoping arm, they have some pneumatics. They go in and out. I don't actually know how those pneumatics. What they didn't want to do is they didn't want to have all that loose pneumatic tubing all over the place, because out in the field of battle, the pneumatic tubing would probably get tangled in things. So what they wanted to do was they wanted to build a spool, and they have a spool of pneumatic tubing. One of the things in the pneumatic kit you get is you get a pivot, a part that pivots. I don't know if it's supposed to pivot or not, or just you'll pivot once, but they turned it into something that can pivot over and over again. So when their mechanisms move down, this spool spools up the tubing into one sort of nice packed tight spool of tubing. So it's just sort of keeping the things clean, sort of keeping all the wires and all of the ropes and everything outside of any pinch points, and they developed this spool. So, unfortunately, that's it for slides. But we could take questions. Are there any questions? Because I could draw on this board mechanisms, other mechanisms.
Well, I got a comment. You keep talking about the rope. If you're using the rope to pull something up, right? Right. You got to be real careful if it's stretchy rope, because what ends up happening is you turn it into a spring, and then all of a sudden, when it does start moving, you suddenly built a trebuchet.
Yeah.
Right. So the two suggestions I would make for that is, well, Spectre wire is kind of a finesse, but if you go to like West Marine and tell them, I need rope that does not stretch, they'll sell you rope that does not stretch. Yeah, well, it actually was a Kevlar base to it, but it wasn't all that expensive. Trust me, you'll start finding yourself saying that a lot more. But you want to stay away from that white and yellow nylon stuff that you hang laundry on, because you're asking for trouble.
And don't use climbing rope either.
Climbing rope has got a spring to it.
Designed to stretch.
So there.
Okay,
And
well,
also pre-stretch your cables and ropes. Wire them up between something and pull a couple of feet out of them, and that'll set the fiber, and then within a few hours, wire your machine and then put a preload. And in some cases, you may even preload it more than what you want your competition, depending on what kind of rope you have.
talking about stretchy things, you won't believe this, but one of the things that stretches is chain.
Oh, yeah.
Yes. So, when I was a young engineer, I thought chain is made out of steel, and steel doesn't stretch at all. Boy, was I wrong. Your chain is going to stretch over its lifetime. Now, from a engineering standpoint, our machines are going to get, 2 hours, 4 hours, maybe at the most 10 hours of runtime on them. It's just, you just don't take these things out every day and you move track balls around.